Hello, everyone. This is Alan Ewing, Executive Director of CBRS Alliance. I'd like to welcome you today to the CBRS Alliance Release 2 Specification webinar. We've been working quite diligently for some time putting together Release 2 and now ready for prime time. And also wanted to be able to give you an overview of what Release 2 is all about. Josh, if you could go to the next slide. So first of all, a little bit of housekeeping for us. If you're joining us today, you are aware that you are agreeing with the terms of the privacy policy and the webinar disclosure that was provided in the event description. Be aware also this session is being recorded for our use. We will be providing a link to the recording after the fact, and those colleagues that may not be able to attend today that you may think would find this interesting, we'll be happy to distribute that link so that they can also listen in. Slide. So a little overview of the agenda, and then we'll get started. Myself doing the introduction. I'll introduce Dr. Gary Boudreau of Ericsson, who will be giving the specification overview. That'll be followed by the Coexistence specification overview from Dr. Hussain of Google. Then the network architecture from Dr. Masoud Olfat, and finally the CBRS Alliance Identifiers from David Crow. And then we will have time for Q&A. If you do have questions, you will notice a questions tab. You're welcome to type your questions in. We will, if there are easy questions or logistical questions, we'll answer them on the fly. If they're more in-depth questions, we will include those at the end of the session. So without further ado, I'd like to introduce Dr. Gary Boudreau of Ericsson, the chair of the Alliance's Technical Working Group. And Gary, please take it away.
Thank you, Alan. Josh, go to the next chart, please. Thank you. So I'll just spend a few minutes and provide an overview of what CBRS Alliance is in the broad context and specifically what the Technical Working Group, TWG, is looking at. So as some of you may know, CBRS Alliance is an industry forum that was created to champion LTE technologies in the CBRS band, which is 150 megahertz of spectrum from 3550 to 3700 megahertz. And this is in accordance with the FCC Part 96 rules. And if you're looking for more information on what that entails, there's a link provided here. You can go to the FCC website under Part 96. And if you go to select Title 47, Chapter 1, Volume 5, it'll provide all the technical requirements as specified by the FCC for Part 96. There's also a number of good informative webinars available, a couple of them specifically on YouTube. One we've indicated the link to here. Just a caveat that this was from June 2015. So a couple of the rules have been revised since then, but the webinar still provides an excellent overview of what Part 96 involves. And if you do a search, you could find other sources and webinars on YouTube for that. Next chart, please. So I'll just talk a little bit about the differences between WinnForum and CBRS Alliance. So WinnForum, or the Wireless Innovation Forum, is an SDO, or standards development organization with multiple committees. And specifically the Spectrum Sharing Committee, the SSC, handles issues with regard to the FCC Part 96 rules, i.e. CBRS, and they work closely with the US government, FCC, and other bodies, Department of Defense, NTIA, etc. It's a technology neutral body. It has many members, many of which support LTE technologies, but there are other members as well. For example, WISPA, the Wireless Internet Service Providers Association, and it can support proprietary technology use in the band. It's responsible for developing requirements and specifications for the SAS, which is the Spectrum Access System, CBSDs, which are essentially the base station nodes, and ESC, which is a sensing network to detect the Department of Defense radar. It also is responsible for developing security methods and protocols for interfacing between the SAS the CBSDs, as well as different SASs in the network. And it's also responsible for developing the certification testing for both the CBSDs and the SASs. So these are the WinnForum requirements above and beyond the requirements that FCC would have to validate from Part 96. It's also specifying coexistence across multiple technologies, and it's looking into this. This is part of the WinnForum Release 2 development, not to be confused with the Release 2 CBRS Alliance. That is ongoing work, not yet approved, but is work in progress, and we just want to mention that in the context of the coexistence discussions for CBRS Alliance, which we'll talk about shortly in this webinar. So CBRS Alliance builds on what WinnForum has defined, and our focus is on LTE technology in the CBRS band. And we build upon and are compliant with the WinnForum standards. So we're focusing on developing technical specifications to support LTE deployments of not only typical legacy type wireless networks from mobile network operators, but also for private networks, neutral host networks, and a variety of multi-service operator networks that we'll get into more detail on in this webinar. There's a focus on LTE coexistence so that different operators who employ LTE technology can expect a level of cooperation that will help mitigate interference between different networks. We're also looking at addressing commercialization issues and business and marketing issues, and there are working groups within CBRS Alliance focused on that, which is different from the technical working group. And there's a broad range of members, not only operators and manufacturers, but a number of enterprise type businesses that are interested in specific verticals. We're also looking at standardizing the 5G NR technology in the CBRS band, which is the evolution of LTE and 3GPP. That is not part of this Release 2 content, but it is being looked at in Release 3, which is ongoing. And that's, those who are interested, is being targeted for completion at the end of this year, 2019. Next chart, please. So just quickly on the makeup of the technical working group, which is responsible for not only developing the technical specifications, but best practices, as well as recommendations and guidelines that can be used from a technical perspective, but also providing inputs into the other working groups in CBRS Alliance. If you're interested in more details on the specific specifications, they can be found at the CBRS Alliance link provided here. We also contribute into other standards fora as appropriate. As we mentioned, we liaise closely with WinnForum. Other ones are listed here. The probably other key one we should mention is 3GPP. So we're building on the 3GPP standards as necessary to provide the additional functionality that's needed in the CBRS band for LTE. Initially, there were 3 working task groups within the technical working group: coexistence, network services, and radio. And in the last year, we've added a 4th one for home network identifiers, and this was to provide guidance and specification for identifiers within neutral host and non-public networks. And David Crow will provide more details on that later in this webinar. Next chart, please. So as I mentioned, the CBRS Alliance builds upon established LTE standards. We mentioned 3GPP. So within 3GPP, there are literally hundreds of different features and capabilities that are being standardized, both from a radio access network and packet core, packet core perspective. And what we're doing in CBRS Alliance is not to reinvent the wheel, but to use what has been specified and build upon it and leverage those standards definitions to ensure we have the correct functionality in the CBRS band that's compliant with Part Part 96 as need be. We also look at a number of other industry standards groups, which are listed here. I won't read them all out, but there are a number of others, and we interact with them as needed to provide clarification on the requirements that we define. There's other areas of requirements, of course, that we have to be aware of and compliant with as well. So in addition to the Part 96 FCC rules, there are other standards such as ATIS to ensure compliance with, for example, mobile alerting, E911, etc. We also have to be compliant with the WinnForum rules, as I mentioned, and any FCC rules from a radio emissions perspective that are above and beyond Part 96. And we layer these on the CBRS Alliance specifications above and beyond what's in the WinnForum requirements. So as a summary, we're essentially exploiting the strengths of the multiple standard bodies that are available and building on those and adding sort of the wrappers as needed to develop a commercial LTE solution in the CBRS band. Next chart, please. So what makes CBRS different? So as many are probably familiar, LTE is designed initially targeting mobile network operators, deploying mostly in licensed spectrum. CBRS, as you're maybe aware, is a tiered use of spectrum. So we could say it's lightly licensed spectrum. There's an incumbent in terms of the Department of Defense Navy radar, which we have to defer to in terms of use of the spectrum. There's a second tiered layer, priority access license, which will be auctioned. That has not occurred yet, likely won't be till sometime next year. And then there's a third general access availability, which is, you could think of somewhat like unlicensed, with the caveats that you have to meet certain requirements provided by Part 96, as well as the overview work with in terms of the spectrum granted by the SAS. So this opens up a number of opportunities and new use cases that are not addressed by 3GPP, in particular for neutral host networks. So we've defined a number of new capabilities layered on top of the 3GPP specifications. A few of those are listed here. Use of a shared CBRS home network identifier, framework within neutral host and non-public networks, device-based authentication, and multi-services operator deployments, and a number of others, which we'll talk about more later in this webinar. Next chart, please. So before we get into the detailed discussions in coexistence and the network aspects, I'll just provide a couple references here. Again, if you're looking for more detailed information on either the Release 1 or Release 2 specifications, they can be found at the CBRS Alliance website. As well, there are webinar recordings for CBRS Alliance Release 1 specification details, which was provided last year, similar to this webinar. And there's also a webinar available for the shared H&I functionality if you're interested in that. So with that, we'll turn the discussion over to Dr. Yixuan from Google to talk about coexistence.
Thank you, Gary. So let's move on to the next slide, please. So this presentation is going to discuss what we have done in the coexistence group in Release 2 of the CBRS Alliance spec. This slide is an overview of the Release 1 spec. We introduced several concepts in the GA coexistence work. First is the coexistence group concept. It is a group of CBSDs that abide by a common interference management policy, which is used to coordinate their interference within the group. For this particular discussion in CBRS Alliance, we create our own coexistence group called the CBRS Alliance Coexistence Group. And we also create a set of policies so that the CBRS Alliance members are going to follow in terms of GAA coexistence. The next concept we created was the coexistence manager. This is a logical entity responsible for managing coexistence between the GA users within the coexistence group, or in particular, the CBRS Alliance coexistence group. And this coexistence manager, or CXM, may reside in a SAS. And then there needs to be a lot of information exchange between CXM and the SAS in order to coordinate the GAA spectrum. In addition to these two concepts from the CBSD side, they can also claim to be in different groups for the GAA coexistence purpose. For example, the ICG group, Interference Coordination Group, is a group of CBSDs that manage their own interference, for example, through network planning, so that they can use the same channel, but they do not have to use the same channel. And if they do use the same channel, they do not have interference with each other. A similar concept, but different, is CCG group. This group of CBSDs that they need to use the exact same channel, GAA channel. For example, they want to help their handover functions. They may prefer to use the exact same channel. So CBSD can indicate the groups they belong to CXM, and then CXM has to consider those information in the GAA channel assignment. Next, please. So what's new in the release to coexistence function? First, we define new functional requirement for the CBRS Alliance coexistence group manager to assign GAA's spectrum resource to CBSDs belonging to what I called earlier, the CBRS Alliance coexistence group. We also define new functional requirements for the CXM to instruct CBSD to use the same LTE TDD configurations in scenarios where the use of different LTE TDD configuration can cause detrimental interference. And on the CBSD side, we define coexistence measurement reports. Those reports are conveyed by the CBSDs to the CXM that contain measurement information regarding the radio environment. And such information may assist the CXM in GAA channel assignment to CBSDs. And finally, we extend the SAS-CBSD protocol to facilitate such new function requirements for both the CXM and CBSDs. Next, please. So first, this is a requirement for the CXM. How does CXM allocate the GAA resource assignment to CBSDs? The CXM uses a graph coloring approach. First, the CXM will create the LTE TDD overlap graph. In this graph, an edge denoted by a line in this graph is created between two CBSDs. Each CBSD is represented as a vertex in the graph. So if that two CBSD can interfere with each other, in other words, they have a coverage overlap with each other, the CXM will create an edge between them. And then after edge creation, the CXM will create a LTE TDD connected set. Connected sets are created in the LTE TDD overlap graph to include CBSDs with directly or indirectly interference relationship. So on the right, you can see this graph. This example shows there are 4 connected sets. And you can see that for CBSDs in one connected set, they are either directly connected with an edge or indirectly connected through other CBSDs. Next, please. So after the CXM creates the LTE TDD overlap graph and then connected sets, the CXM will try to color each CBSDs. The GA channel assignment is basically performed independently in each connected set because between different connected sets, they do not have interference relationship. Therefore, the CXM can treat each connected set independently. And a group of CBSDs may indicate that to the CXM that they need to use the same channel. This is the concept of CCG that I mentioned earlier. And then the CXM will color the vertices in a LTE TDD connected set with the minimum number of colors, such that the two vertices with an edge between them have different colors. So this is the conventional graph coloring approach. But this graph coloring result can be used. We use this graph coloring result to determine how each CBSD can be assigned with GAA channels. Basically, available GAA spectrums will be equally divided by the number of colors in a connected set. And each CBSD is assigned the GAA spectrum associated with the color it gets. Right, so this is the general approach for GAA channel assignment that is performed by CXM. Next slide, please. So in addition to GAA channel assignment, the CXM is also responsible for selecting LTE TDD configurations in order to avoid interference caused by different use of TDD configuration. For multiple overlapping LTE TDD deployments to coexist, it is desirable if CBSDs in such a deployment use the same TDD configuration. The CXM creates connected sets for TDD configuration determination first by using creating edges between CBSDs that have coverage overlap of their respective minus 96 dBm per 10 megahertz contours. So if they have such a coverage overlap, the CXM will create an edge, like I mentioned before, and then create a connected set accordingly. All CBSDs in such connected set shall use the same TDD configuration. If conflict of TDD configuration happens, a mandatory TDD configuration, as shown in the table below, the mandatory configuration can be either configuration 1 or configuration 2. One of the mandatory configuration will be selected and signaled by the CXM based on the majority voting among the fallback TDD configurations specified by the CBSD. I will talk more about the fallback TDD configuration in the protocol part of the slide later. Next, please. This slide is about the CBSD requirement for coexistence measurement report. The coexistence measurement reports are provided by the CBSDs to assist CXM in CBSD channel assignment with measurement information regarding the radio environment in the vicinity of the CBSDs. So in addition to counting on channel propagation modeling, CXM can also make use of such a measurement report to determine the interference of CBSDs. A coexistence report may provide identification information, measurements, usability, and the tolerability indications, and that the information can pertain to the channel currently in use by the CBSD or to other channels. Measurements included in the coexistence reports can include measurements like RSSI, RSRP, RSRQ created by the CBSD. It can also include the histogram of RSSI, RSRP, RSRQ measured by the UEs. And this is, I want to emphasize, this is optional for the CBSD to send the measurement reports to CXM. But we have defined the protocols that is available for CBSDs to use it. Next slide, please. Yeah, we are going to use the SAS-CBSD protocol extension to carry a lot of the information from CBSDs to CXM or from CXM back to CBSD. Can you click through the slides to show the whole figure? Yeah, the first part is from the CBSD to the CXM or SAS. For CXM or SAS, we put it into the same box because the CXM can be a logical entity residing in SAS, and then there needs to be a lot of information exchange between SAS and the CXM. We use the SAS-CBSD protocol to send the information from CBSD to CXM, as well as sending the information from CXM back to CBSD. From the CBSD to CXM part, we use an object called a grouping param. This object can be sent through registration request, spectrum inquiry request, or grant request. This is an object defined specifically for CBRS Alliance. We indicate this object as coexistence group type and then group ID as CBRS Alliance. Next, please. From the CXM to the CBSD or domain proxy, we use another object called the grouping config. And similarly, this grouping config object can be sent through all the responses like registration response, spectrum inquiry response, grant response, and heartbeat response. Next slide, please. So what's new in the SAS-CBSD protocol extension? For the new information from CBSD to CXM part, we include the fallback TDD config. This is for CBSD to indicate to CXM what is the fallback TDD config it prefers. It has to be one of the two mandatory TDD configurations, as I mentioned earlier. And in case there is LTE TDD configuration conflict within CBSDs in a connected set, then the CXM will use this fallback TDD config to do a majority voting and then determine one of the mandatory TDD configurations to be used by all the CBSDs in a connected set. Also included in the CBSD to CXM communication is the cell information. This is the information about the LTE signal transmitted by the CBSD. And this information can be used by CXM to identify CBSDs making the measurements. And then finally, there is a coexistence measurement info. This is a pretty large object. It can include all the information of CBSD measurement reports. From the CXM to the CBSD side, we have an object called the Coexistence Measurement Assistant object. That includes assistant information for CBSD to perform coexistence measurements. And then CBSD can use that to perform measurements and then send the measurement reports back to CXM. And the next object is the CBSD frequency guidance. This is the object for CXM to tell a CBSD regarding the frequency range the CBSD is instructed to request from the SAS. Basically, this is the GAA channel assignment from CXM to CBSDs. Okay, this concludes my presentation on the release 2 coexistence. Thank you. Masu, I guess you are the next.
Okay, Good morning. Can I be heard?
Yes.
Okay, good. Good morning. Thank you, Dr. Sean and Dr. Boudreau and Alan for introduction. Before I start going through the network architecture, by the way, can we go to the next page, please? Josh? Yeah. It's important to mention that what is specific to network architectures for CBRS. Obviously, CBRS can be deployed similar to all other bands in a typical regular 3GPP model, and such as MNOs and others to use the CBRS spectrum and run their own network, similar to all other LTE bands. And from that perspective, there is not a major difference between CBRS and other bands. However, as everybody knows, CBRS is one of the major advantage is in addition to an additional band in a very critical spectrum location, mid-band, which is critical for, as everybody knows, for LTE and also 5G globally. But in addition to that, CBRS is a great enabler for the small cells, the enterprise network, private network, neutral host, and the type of networks that are not necessarily conventional in terms of the MNO deployment. So from that perspective, in order to facilitate and enable the deployment of those type of use cases in CBRS band, it is critical that CBRS Alliance look at the potential changes that are required to facilitate those use cases. So that's how this network architecture task group under the TWG was created. So and our scope mainly was to not to necessarily change the existing standards. We are completely relying on 3GPP specifications, and if needed, if there is any area that some changes are needed to facilitate CBRS deployment, then we work on that. So that's the goal and scope of this. In addition, we are looking at some other standard, as Dr. Boudreau mentioned, such as Multifier Alliance and IETF and other standards that can be reused. So our goal is to reuse as much as possible the existing standard. And if needed, then we come up with some modifications. So with that, the release 2 has been mainly focused on some areas, for example, looking at kind of revisiting the release 1 network architecture, which defined the neutral host and private network, and created the basis for CBRS network architecture to align with the shared HNI for private network and neutral host. Mr. David Crow is going to go through the detail of that. Just give you a quick one sentence. Shared HNI is the PLMN ID that is going to be available for all users of the CBRS Alliance, which is one single PLMN ID that everybody can use. So the fact that one PLMN ID is used with multiple networks, that creates some requirement to do some modification and make sure that no confusion happens for the UEs. Then we redefine the UE profiles. There are some UE profiles defined in release 1, and we redefine them. I'm going to go through them. We look at some new requirement and use cases and network architecture for some use cases, such as fixed network model and multiple system operator MSO model, as well as we define the CBRS non-SIM-based security framework, including certificate-based UE authentication for that could be potentially applied to private network. You are aware that currently there is a work item in 5G NR that is looking at the same issue. So next page, please. So the very general framework, of course, for different use cases, we have much more detailed network architecture, stage 2 network architecture. Then I invite you to look at the TS1002, the technical specification number 2 from the network services task group, and you can see the detail. So what we are doing, we are defining some IDs, calling that CBRS identifier and CBRS needs CBRS network identifier to distinguish the network. So CBRS, without CBRS, as I mentioned at the beginning, CBRS can be used in a conventional network without CBRS I, as you see on the left, as well as specifically configuring the UEs to work with the CBRS I and the CBRS need provided by the CBRS RAN. And this CBRS RAN could be of many different types. For example, it could be a private CBRS, it could be a conventional MNO, it could be MSO, it could be a neutral host, or a hybrid of them. Next page, please. Yeah, so as I mentioned, a CBRS-I is a PLMN ID that is used by the CBRS network. It could be either a regular PLMN ID that is allocated by a US IMSI administrator, or it could be a shared HNI, or it could be an operator-specific PLMN ID. Also, it can be used as a, we have defined the concept of supplemental CBRS identifier. It's an operator-specific PLMN ID that is used as CBRS-I. And this CBRS-I is, like the PLMN ID, is broadcast in the SIB1, the System Information Block 1, in the PLMN identity list. And of course, everybody knows that in the United States, it's the IMSI administrator that manages these resources. CBRS need is the identity of the CBRS LTE network. Specifically, if you are using the CBRS-I is shared, then we can use the CBRS need to identify. Also, by using one CBRS-I, we can identify different networks that are using the same CBRS-I. For example, an owner of a stadium might have different deployed with the same CBRS-I in different venues, and the CBRS need would be able to identify those different venues. It is a 27 bits that is broadcast in the SIB1 in the CSG identity field. And knowing that if CBRS-I is the SHNI, then CBRS need has to be unique for within the SHNI. And then we have the CBRS network name, which is a meaningful name of the CBRS Alliance network, either NHN or private network. It is presented to the end user doing kind of manual network selection, and when UE is attached to the CBRS Alliance network. It's a 48-character string that we include that in the SIB9, and the field that we are using to do that is HNB name. Okay, next page, please. Great. So UE profiles, because of the use cases that we have defined for network architecture, we are kind of categorizing UEs in different profiles. And by the way, support of these UE profiles are optional for the UEs. It doesn't mean that UEs have to maybe profile 2 or profile 3, but the UEs can pick one of these. For example, profile 1 is the normal LTE UE that supports CBRS band. So no necessary configuration for CBRS-I or for authentication is done at the profile 1. Profile 1A is the same UE that is not configured with CBRS-I or anything else, but it supports something called 3GPP based access mode, which is Non-EPS-AKA, which I'm going to explain in the next page. But in summary, that's the non-SIM based operation. And of course, profile 1 and profile 1A, either they can camp on a service provider access network, or they can be connected to the service provider, either RRC idle or RRC connected. Profile 2 is the UE types that are kind of having one radio, but they can have different EMMs, the element management, element mobility management, and they can be camped on service provider either as an RRC idle mode or RRC connected, or they can camp on a CBRS Alliance neutral host in RRC idle or connected. So these are the profile 2 is the minimum set of requirements and the characteristic of the UEs to be able to operate with CBRS Alliance neutral host. Profile 3 are the ones that are capable of accessing to multiple networks simultaneously. Keep in mind, Profile 2 is can access to one network at the same time. However, Profile 3 allows the device to connect to multiple networks simultaneously, and those networks could be a service provider network as well as neutral host for different applications. So, for example, you can be communicating to the neutral host for data communication, but at the same time communicate with the service provider network for VoLTE and IMS-based services. It can optionally support 1A, which means that we can use the non-USIM-based authentication. Profile 4 is the same as Profile 3, but it allows dual radio. So at the same time, we can have two different radios and dual connection at the same time. And Profile 5 is the device that has multiple subscription, but it has single radio, and it's basically capable of setting an SW tunnel via the EMM registered access network. So the Profile 5 can also optionally support Profile 1A, and it can attach to service provider network using the either AKA mode or non-AKA mode. Next page, please. Okay, good. So what we have done in Network Services Task Group in Release 2, we have defined two main mode of operation. One is called 3GPP access mode or EPS-AKA. This is the mode of operation that the network supports all function and procedures defined by 3GPP, including the EPS-AKA authentication. So this is a normal UE operation per 3GPP LTE that includes EPS-AKA or EPS-AKA prime for authentication, and all of the stage 3 functionalities comply with the 3GPP EPS stage 3 functions. Next page, please. So the next one that we are using is called the 3GPP-based access mode or non-EPS-AKA. This is the mode of operation that I'm just showing here the architecture, the detail of the stage 3 is included in our document, this TS1002. This is a mode that UE performs authentication without the use of EPS-AKA. For example, you can use IP-TLS or IP-TTLS in 3GPP. It supports all 3GPP function except the non-EPS-AKA method for authentication. And in this case, the UE can authenticate without using a USIM. Next page, please. And by the way, I'm sorry, before you move, so in this figure, we are showing some of the areas that potentially might change. For example, of course, UE has to support that. We are calling it the MME that supports that mode of operation, MME prime. And of course, for that, there is a need that the MME prime communicates with a potentially non-3GPP AAA if we are dealing with a non-3GPP network. Next page, please. So some of the changes that are required for this 3GPP-based access mode non-EPS-AKA are the change to the attach process. The attach process is changed using with the non-USIM credential. The way that the tracking area update procedure is defined in 3GPP document 23401, is changed, because in that in a step that authentication is required. The service request procedures in the document 23401 is changed. The detach process is changed. The handoff, when we are doing handoff, and especially provide the context to the target eNode B. In that case, we provide the non-EPS-AKA context. The user credential and subscriptions without USIM, eSIM, and UICC. In that case, these credential and subscription have to be stored in something called ME, the mobile entity that is separate from the USIM. And also, basically, the process of rejecting a UE, attempting to access to an IMSI that they do not belong to network using CBRS Alliance, CBRS-I. So these are the changes that requires for this non-EPS-AKA operation that all defined in the TS1002. Note that, interestingly, the PCRF policy control is not necessarily altered for this case. Next page, please, and this is the last page. So finally, without going through the detail, from a fixed network perspective, we didn't see necessarily a major difference between the regular 3GPP and the CBRS Alliance network. So we realized, as I said, not as a specification, but as a guideline, that the CBRS Alliance for fixed network deployment, we can use it either through basically fixed wireless deployment by a service provider using a tunnel between the residential gateway and the access network, or without the tunnel. In that case, the LTE network directly connects to the service network, such as internet, and in this case, no tunnel is used. Or we can use a tunnel and use the fixed wireless deployment by the NHN operator, by the neutral host operator. So all these three can be used, and for them, not necessarily changes. No necessity is required. No change is required to existing 3GPP as well as the neutral host specification that we have defined here. So with that, I'm done, and I will look for questions. I will hand it to David Crow for HNI description. Thank you.
Okay, I'd like to talk about the identifiers that are going to be used in CBRS systems. If we could go to the first slide. Okay, so CBRS systems are using LTE, so they need IMSI to identify UIM cards, cells, or eNode Bs, etc. So why can't we just use the regular identifiers? Well, the problem is that the US only has 700 unique IMSI blocks, and with the small systems that will be facilitated by CBRS, there could be thousands of systems. So there wouldn't be enough IMSIs if every operator had a unique IMSI block. So the CBRS Alliance arranged to share one block, which is the HNI 315010, among all the CBRS operators that don't have their own full-sized blocks. And this would be broken into 10,000 sub-IMSI blocks, each of which will have 100,000 unique IMSIs. And this breakdown will also be reflected with cell IDs. Can we go to the next slide, please? Okay, so this is a summary of the CBRS identifiers that are affected by the shared HNI. So obviously the IMSI will be prefixed by the 315010 shared HNI. And then there will be an IMSI block number assigned, and then there will be UINs, or the individual numbers. The NID is also important to CBRS. That is the repurposed CSG ID. And it is independent of the shared HNI, but it works in concert with the shared HNI. The GUMI identifies the mobility management entity, and part of that is assigned by the CBRS Alliance. The cell IDs, or the ECGI that I already mentioned, it also contains the shared HNI as a prefix. and so does the target area identifier, TAI. Can we go to the next slide, please? So when it comes to obtaining identifiers, the IMSI administrator, the US IMSI administrator, which is iConnective under the oversight of ATIS, will assign IMSI block numbers within the shared HNI for an individual and ongoing annual payment of $350. And that's probably the first step for a lot of operators. So that gives you 100,000 IMSIs, and it also allows you to use the shared HNI prefix for other identifiers. The CBRS Alliance itself, or an entity that it designates, will assign the network ID, the 27-bit number that uniquely identifies a CBRS network. And it will also hand out blocks of ECGI, so that these identify cells or eNode Bs. So the number of codes that are assigned will be up to the operator to request. And as I mentioned earlier, the GUMI identifies the mobility management entity, and a CBRS operator can be assigned one or more of these identifiers. The tracking area identifier is also important. These will not be assigned by the CBRS Alliance, but they will be recommended based on the shared HNI. And the proposal from the CBRS Alliance is that there will be small initial payments depending on the number of identifiers that are requested, and also ongoing annual payments to maintain the assignment. The next slide, please. Okay, so some useful documents that if you're interested in identifiers, you will probably want to look at. So on the ATIS website, atis.org/IOC, you can find the shared HNI IMSI guidelines. And the CBRS Alliance itself has produced 3 reports, 0, 100, 101, 102. The first of which is basically an overview of the identifier guidelines. 101 is the specific administration guidelines, the rules for obtaining identifiers. And 102 is the database and user interface design for the system that will manage the identifiers. And with that, that's all that I have.
Well, very good, David. Appreciate everybody. Somebody's still live there. Appreciate everybody presenting today. We have had a question come in. If you would like to ask a question, there is the Q&A or question panel that you can type into. I'll read out the first question and ask our panelists to perhaps Gary, you'll take the lead on it. I understand support for the different UE profiles is optional, but do we have any insight onto which ones UE manufacturers might support in the future and when? I assume it will take a major operator to push adoption. So Gary or any of our panelists?
Masood, did you want to address that one?
Yes, yeah. So thank you for the question. So to be very short, it is correct. So basically, obviously everything depends on the ecosystem and the business model that is introduced. It's up to the operator to pick. Obviously, but the point is that if, for example, anybody wants to use a non-SIM based operation in CBRS Alliance, then the use of either Profile 1A or Profile 5 is needed. Without that, they cannot really use that mode. Or, for example, if somebody wants to operate within a neutral CBRS Alliance neutral host, then Profile 2 is the minimum that they have to support. So depending on the use, the operator can choose, and whether UE manufacturers do that or not, that's based on the business model and the ecosystem.
Good. Thank you, Masood. Thank you, Gary. Another question just came in. Is there any TRP and TIS requirements for IoT devices?
Can I?
Gary?
Go ahead, Masood.
Oh, Masood.
So keep in mind that the CBRS Alliance, the UE operation from a radio perspective is normal, and we don't have a specific testing for the UEs as long as they, based on the FCC Part 96, they are characterized as UE. So no, not the specific either TRP or TIS or any particular test for UEs is needed for CBRS.
We have a little bit of noise there. So I think though, Masood, you came through clearly. So thank you. Next question we've got here. For fixed wireless deployments in a crowded GAA coexistence environment, how are CBSDs guaranteed to be granted the same channel as the serving BTS CBSD?
Hi, may I take the question?
Yes, please.
Yeah, so I think, yeah, that's a very important use case, and that's why we in CBRS Alliance define some grouping information. The particular grouping type that can be used for this purpose is CCG. It's called a common channel group. So the CBSD and the base station CBSD, they need to claim that they belong to the same CCG. In that case, if they indicate they belong to the same CCG, the coexistence manager will always make sure that they will get the same GAA channel. So the CBSD can communicate with the base station CPE with the same channel.
Okay, thank you. Another question coming in, is there a use case where CXM may reside in the domain proxy instead of the SAS?
So this kind of architecture was discussed in CBRS Alliance. I think that we currently do not define the interface between the CXM and the SAS. So as long as the CXM and the SAS can communicate necessary information efficiently, the entity, the location of the CXM is not being mandated by the CBRS Alliance. We consider the CXM may be part of the SAS, but as you said, it may be located in other locations as well.
Very good, thank you. So I think we have one question here. It's probably a good one to wrap up on. What are the next steps in the timeline to verify and validate release 2? So Gary,
sorry, I can take that one.
Yeah,
Alan.
please.
So yeah, to be clear, so the release 2 specifications have been fully approved. They've gone through an extensive review process last year with actually some of the multiple review processes in terms of detailed comment resolution. So they have been officially approved both by the TWG and by the Board of Directors in CBRS Alliance. I guess if the question is asking in terms of test and verification of specific requirements, so we have produced test requirements matrices, and we're working with the test and certification work group within CBRS Alliance to develop the specific test cases for both for CBRS Alliance CBSDs specifically to meet those requirements both from the NSTG and the Coexistence task group. So verification to the release 2 specifications will be ongoing as a future process.
Very good. Well, thanks, Gary. Thanks to all our presenters today. Very much appreciated. We are up against our time now. Look for this presentation, a recording of this presentation to be available on the CBRSalliance.org website, as well as some of the slides that were also presented today. I'd like to thank everyone for their attendance and their interest, and always feel free to reach out with questions via our website contact page, or if you are a member company, of course, you know how to and who to contact for specific issues. Thanks again for joining us today, and with that, we will close our webinar. Have a good day.